Dear colleagues, dear friends, good morning in the States, good afternoon in Europe, good evening in Asia. My name is Vasilis Vasilikos, and I'm a professor of cardiology in the University of Thessaloniki, Greece. And I'm also the president for the International Society for Holter and Non-Invasive Electrocardiology. I would like to welcome you to this second webinar, which is a joint webinar between our society and the European Heart Rhythm Association, EHRA. And we think that we have to give the more chances to the young EP generation. And we have planned this webinar with the young EP, the young communities from ISHNE and from EHRA. Technology is in our life. Almost everybody has an arrhythmia sensor, a mobile phone, a smartwatch, and the patient has started using this, and lots of data are accumulating. There are also some issues regarding this technological advancement. In this webinar, we want our young communities to let us know their opinion about these wearable sensors, the AI, and how this is going to change the arrhythmia monitoring and ECG analysis. So we have two teams, the ISHNE Young team and the EHRA Young team. And we have a commentator at the end, Professor Neeraj Varma from the States. I would like to welcome you all on board, and I have the honor to co-chair this session with Professor Adrian Baranchuk from Canada, who is the president-elect from ISHNE, and Professor Marquez from Mexico, who is the vice president of ISHNE. So, Adrian.
Thank you very much, Vasilius. It is a real pleasure to share with you this second webinar from ISHNE. On behalf of all the ISHNE team, we want to thank Dr. Vasilikos for his dedication during his presidency to create these platforms where now the EHRA and the ISHNE young communities can interact and show us how technology is evolving. So in this sense, it is my tremendous pleasure to introduce the first speaker, Dr. Tomasz Jacek, who is one of the members of the EHRA young community. And today he's going to give us a first perspective in the topic of wearables and artificial intelligence applied to this specialty. So with no further ado then, I would like Thomas to take the command and be able to present the first one of this series of presentations. I'm not sure if there is a technical issue, but I can't see Thomas coming in. Let's see. Here he is.
Yeah.
Okay, Thomas, the floor is yours.
Thank you very much. So I would love to see my presentation. Thank you. Improvements in sensor data handling and actually everyday gadgets have led to rise of wearable technologies. My name is Tomasz Jacek, and I will be happy to share with you best practices in implementing these novel technologies in clinical practice. So smartwatches and fitness trackers represent the cutting edge of what is going on the market and in the clinical space as our patients use these new gadgets. And when we say wearables, we mostly think of smartwatches, but please take a look. The landscape of digital health devices is much broader. Please see there are almost 20 different sensors you can actually wear. So this is really fascinating. Now with AI, even your earbuds can be transformed to so-called hearables. This is a project developed by Professor Cecilia Mascolo at the University of Cambridge, and I'm really fascinated about the results. And during today's presentation, I will try to convince you that wearables are great and that they impact our daily clinical practice. I also hope my colleague Konstantinos, who is the next speaker, will challenge my message. So at the end of the webinar, you have a well-balanced piece of information. I mean, it seems we cannot escape from wearables. This is a report from Deloitte Consumer 2024 report, and it shows that more than 50% of adults use smartwatches and fitness trackers. So this means that sooner or later, one of our patients will confront us with the results obtained by one of these new devices. So let's be ready for this. In a broad aspect, digital health technologies record behavioral and or physiological data. Here you can see wearables supported by software. More and more often it's artificial intelligence. They are increasingly being integrated in a range of contexts in cardiovascular medicine to support patient care, of course, clinician interactions, but also workflows. And here you can see two main technologies behind the most popular wearables: photoplethysmography, PPG, and ECG. PPG is based on reflected light and it generates a pulse wave. PPG can measure heart rate, while abnormal rhythm can be detected by algorithms. On the contrary, ECG-based sensors give us information about rhythm, and you can see how the PPG and ECG correspond to each other on this figure on the right. For the ECG and holters, we are very much familiar with contemporary portable devices designed for health monitoring. They are clinically grade medical wearables, and they have a specific clinical intended use, and they are approved by the regulator. Also, ECG-based wearables are beginning to be implemented in clinical practice, of course, and this is a result of a survey on physician preference in using digital devices for management of AF in 3 groups of patients. Results show that the symptomatic, low-risk AF groups, for this group, doctors would choose wearable ECG in case Holter ECG is negative. So this indicates that physicians trust wearable devices and consider them, we can say, maybe as a second-line diagnostic tool here. In contrast, consumer-facing devices typically have regulatory clearance for over-the-counter pre-diagnostics. Of note, some of these devices may provide the user with a provisional automated interpretation of sinus rhythm or atrial fibrillation. They have different specificity, sensitivity, so of course you can expect some patients will get false positive, false negative results. In general, they are not approved by the regulator, for example, Fitbit. Interestingly, Apple Watch is an over-the-counter device with FDA approval, but FDA approved the ECG app, a software which is combined with the watch. So let's read what is given in the FDA approval. This software is to supplement rhythm classification and not to replace traditional diagnosis and treatment. So today, wearables generate a lot of data, and we need some AI tools, algorithms to process this huge amount of information. Here I plotted an evolution of AI models for wearable devices, starting from algorithms on the left, where each data point was treated independently. So each measurement was a separate value. That was at the beginning. Nowadays, there are more advanced algorithms like transformers, which identify relationships across much longer sequences. So this gives us, more valuable and clinically valuable data. Just to give a bigger picture, AI has much broader application. Not only to analyze data from wearables, AI can be used to support diagnosis, provide more accurate prognosis, or improve workflow. But in fact, how to integrate wearables into clinical environment. First of all, data are collected from patients with wearables. That's obvious. Data sets captured centrally allow for integration into the electronic health record system. It means we have all data in one place. This provides support for physicians making evidence-based decisions. And where is the place for AI? It's here. So artificial intelligence or automated algorithm can facilitate the whole process. And please note, that's pretty important with wearables. We deal with younger, probably a little bit healthier population, and this will have implications. And today I will let you know why. Now, some real life cases. Imagine your patient sent you an email, you open the attachment, and there it is, AF. Okay, so 1, 2, maybe 3 emails a day would be okay. But if you start to get like 5, 10 emails a day, how to deal with that? There is a need for some kind of a framework or solution, to deal with this number of data coming to you for the analysis. So here I would like to share with you the Basel Wearable Clinic, which is an online platform where patients can upload their ECGs obtained with wearable device simply by sending their ECG tracing in PDF format. The Basel Wearable Clinic is an excellent, actually an excellent example of AI-assisted wearable ECG analysis. And these are the results presented at the ESC last year in London, the results from Basel Wearable Clinic. So you can see there are up to 25-26% of AF, and the population was rather healthy, CHA2DS2-VASc of 1 in average. And as presented at the ESC, the study showed that, or confirmed that, subclinical AF can be diagnosed in younger population with wearables. Of course, if you collect so much data with wearable devices, sooner or later you will detect AF in asymptomatic patients. And of course, the question is what to do when you have it. Put the patient on NOAC. This is one point. But another point is that when you have a younger population and we diagnose a subclinical AF, maybe we should look for risk factors. There must be something triggering AF in young person. So, if the patient is young, there is a bigger potential for improvement with adequate early clinical intervention. So diagnosing subclinical AF with wearable is a chance to screen for risk factor here. So there is another very important point. To successfully implement wearables or any new technology in clinical practice, we need patient engagement. Ms. Inga Drossard, ESC Patient Forum member, shared her perspective during last ESC in London. It was really interesting, actually, to understand, when patients want to use wearables. The answer is mostly in acute health issues, with acute health issues. Using a wearable, the patient would like to know, shall I seek care or not? So is my problem, my medical problem, a serious thing? Then if I need a doctor, should I go to the emergency department, or I can wait and make an appointment at doctor's office? Finally, as a patient, I want to speed up diagnosis and prevent any deterioration. And of course, I want to save my time and resources. This is another point. And Ms. Drossard also shared an interesting survey from patients in Germany, asking these patients about ECG monitoring with wearables. So almost 60% said that they would use wearables for rhythm monitoring. However, almost 30% said, no, I don't want to drive myself crazy. So you see, uh, there are different approaches and different expectations. Thus, it is really important to talk with patient about wearable monitoring, assess their readiness, and select the appropriate technology. Of course, if needed, educate them, and at the end, agree on a monitoring plan. In short, patient must like the technology to use it. So thank you for your attention. I'm happy to answer any questions, and I can't wait to hear Konstantinos's arguments and dilemmas, challenges. So friendly, on guard, and let's discuss further. Costas?
So thank you very much for the participation in the webinar. I really enjoyed your presentation, Thomas, and looking also forward for the next talk. As healthcare professionals, we have to face the new reality. Billions of wearables are already used, and as you said, you mentioned previously, 50% of adults use already this technology. So it seems that wearables open new avenues for earlier detection and treatment of arrhythmias. But we also know that the longer you monitor, the more you discover. So which patients should use this technology? I think for asymptomatic individuals, this is the main pool. Wearables seem to be valuable only for those who will potentially be treated in the future. For example, patients with high thromboembolic risk, cryptogenic strokes, or older people. These patients need a systematic screening, and this can be with wearables. And I would like to stress that even a 30-second single lead ECG is enough for AFib diagnostics. And according to the new AFib ESC guidelines, these patients may even qualify for a DOAC treatment with a class 2B indication. In terms of arrhythmia management, generally, I think that the wearables are of limited value in low-risk younger patients, as you said. These patients, there is still a general benefit for risk factor management, as you said, and they can also increase. It can also increase their motivation for exercise and for a general health monitoring. So the first step is to identify the high-risk patients, and this will also help to avoid data overload, which is the major fear, a problem coming with widespread use of wearables. And here the role of AI is obvious. Before reaching the healthcare professional, AI algorithm may increase the accuracy of the wearables. The current value of accuracy in the wearables ranges between 60 and 80%, not a perfect one, but AI may improve it. And this will reduce, of course, the burden of our work, and may even reduce the need for healthcare visits. Other future perspectives for wearables, I think that they may lead to an individualized patient-oriented approach. We know that one size does not fit all. And for example, there are ongoing trials which examine the feasibility of non-continuous use of DOACs based on wearables data. So if the patient has AFib, starts a DOAC and stops it after a month, we're expecting the results of these trials, which are interesting. And of course, there are still a lot of emerging issues that should be discussed and addressed. We will go deep into them since they're going to be discussed in the next session. Looking forward to Konstantinos' talk, such as privacy policies, who owns the data, digital literacy, etc. And finally, a major issue for clinical practitioners is, of course, the reimbursement issues. I hope we will discuss them later. Thank you very much.
Thank you, Konstantinos.
Okay, thank you very much, Thomas and Dr. Trantafilou. I would just like to mention the biography, a brief biography of Dr. Constantino Trantafilou. For those who don't know him, he's a cardiologist and electrophysiologist at Hippocatrium General Hospital in Thessaloniki, Greece, and he was EHRA Young EP ambassador for Greece in 2022, and currently is the EHRA Young EP committee member. So thank you for being here with us this morning, Dr. Triantafilo, and we will continue with the meeting. So our next speaker is Dr. Konstantinos Bakoyannis from the ISHNE team in this time as a speaker. He's also a young member of ISHNE, but now he's as a speaker, and he has the challenge to talk to us about challenges and dilemmas in implementing in daily clinical practice wearables and artificial intelligence arrhythmia monitoring. Thank you very much, Bakoyannis.
Dr. Marquez, Manuel, thank you very much for the introduction, and thank you very much for this very interesting meeting. And I want also to thank Dr. Triantafilo, Kostas, and Thomas for making it happen, the joint meeting with EHRA, but also to congratulate them for the presentation and the very important comments from Kostas, because it will make my job easier, I would say. So, while arrhythmias, I think that in this webinar we don't have to spend a lot of time, because it seems it affects a lot of people, and it would be one of the next pandemic, especially when speaking about atrial fibrillation. And of course, wearable technology is here. We are living in a fantastic era, I think. We have a lot of tools, a lot of gadgets, and Thomas already mentioned that. But now these are the dilemmas and the challenges that we may face, or we face in our effort to implement and correctly implement in our daily life, both as healthcare professionals, as normal individuals, or as patients with arrhythmias. So the first issue that I will raise is wearables accuracy and reliability issues, as well as the current limitation of artificial intelligence algorithms. So you can see that there we have both the cardiac electrical activity sensors, like the single lead ECG devices, but I would say that more common are in the general population the photoplethysmography devices, the optical and laser PPG devices. So, and we're coming to one of our very interesting, although this publication is from 2021, but still it was one of the first that correctly or tried to, in a more systematic way, to address possible challenges that we will face, as well as sources of inaccuracy in wearable devices. And they've tried to measure the accuracy of heart rate at rest and during activity between various devices, common, commercially available, like Xiaomi, Apple Watch, etc., but also the heart rate measures across various skin tones. And as you can see here, it seems that there was no significant correlation between skin tone and heart rate measurements, but it seems that during the activity, that most of the wearables they showed higher heart rate compared to ECG. Can this affect the measures when we're speaking, or the signals that we are taking when speaking about arrhythmias and irregular heart rate activity? And now AI, if we can say that in very simple words, for 3-year-old children, there are two things: algorithms and data. And you can imagine from both sides that there are limitations or challenges that we should overcome. For example, the appropriateness. Is the algorithm that we use matched to this specific context and this specific population? We have seen that there are some algorithms developed for atrial fibrillation, for example, for early prediction or for diagnosis. Is it correct to use them also for other arrhythmias? Explainability is a big issue. We should understand, where, as doctors, I think that we have this way of thought. We want to know so that we can explain to our patients and to us how we derived this outcome from an algorithm. I should admit that the explainable AI, a new field, they are giving a boost to better understand the way that the algorithms work, and of course bias. I think that is an issue that it is quite challenging to overcome. And we're speaking about bias. It is actually transfer of human problem of discrimination or prejudice in complex decisions, and we can feel it also in our daily clinical life, or even when we're challenging case reports from another countries, from another group of people or group of patients. So, and here a crucial point is the role of data sets, and we have already discussed, and I think that we all know this big issue and challenge. And of course, we have the clinical validation and the regulatory hurdles, and the data privacy, security, and ethical concerns that we should also keep in mind. For example, we don't have a common or a global or a standardized protocols in order to validate both wearable devices but also AI algorithms. So there are also variation and different approaches among other countries. And of course, this is my common feeling. In most of the countries, we see that there is a lack of flexibility when speaking to change and to make, let's say, the regulatory frameworks more user friendly. Of course, data. As Kostas mentioned, who owns the data? The data is very important. And of course, the data privacy laws, you can see that the privacy laws differs around the world. So, and I think that we should invest a lot of energy in order to find a common ground how we should manage data and the data privacy. I feel that there is also a lack of trust when speaking that AI could drive medical decisions. And of course, there is cybersecurity. Security is a very important and a challenging issue, and that we should always keep in mind and work closely with the IT and the developers to address these points. And of course, we all know that integration into clinical workflow, as well as the psychosocial impact of integrating these devices in our daily lives, what this will mean. So you can see now, you can see in this study published in JMIR, in Journal of Medical Internet Research, that is a systematic review and meta-analysis from various studies that addressed the accuracy of smartwatches. You can see here that we have a higher diagnostic accuracy, but still we have a positive predictive value of 85%, and of course a very relaxing negative predicting value of 100%. So we should also keep in mind, and we should also think how we will manage false alerts, how we will integrate and the interoperability between all these devices into EMRs, and of course, as already mentioned, the reimbursement, how we will manage and how this will be reimbursed in our daily life. And now one of the most interesting papers that was recently published from Dr. Rosman, and Professor Varma is also part of this excellent effort, showed us that the wearable users with AFib, with diagnosed AFib, reported higher rates of symptom monitoring and preoccupation. And they also, we've seen also from this study that AF-specific healthcare use was significantly greater among wearable users. You can imagine what this could mean. There is a transition, there is a change, both at an individual level that has to do and directly might affect the psychological status of a patient or of an individual, and both the healthcare system, as we will have more and more patients with diagnosed with arrhythmias or with false alerts, as already mentioned. And of course, I strongly believe in digital health literacy. It matters a lot. It is already mentioned. This is a new language. This is a new era. and we should learn how we will manage this information, how we will manage all this technology, and how we can be wiser and use it with more wisdom in our daily life. So you can see in our clinic we have started, and we are the last 3 years we're investing a lot with this cardio school in educating patients, and at the same time also educating ourselves on how to use digital tools. And now on Friday we will be in Larissa, in the city near Thessaloniki, where we have a digital awareness workshop. So as a summary, if I have to suggest to you, this state-of-the-art paper is very nice written, very nice structure, and addressed most of the issues that I have already presented. And if I have to give and let's say share with you some of the key messages from my point of view, is that of course wearables and AI have a great potential, but we must overcome significant challenges to fully integrate in our clinical practice. AI should support but not replace clinical judgment. That is very important. And I think that is both a shared responsibility and a great opportunity for all of us to positively influence the future of arrhythmia management. So thank you, and I want to invite you also in our Congress, the ISHNE Congress in Thessaloniki, the 30th of May, which I hope that the weather will be great and you will enjoy it. Thank you very much.
Thank you very much, Dr. Bakoyannis. It's a pleasure to have you with us this morning, and excellent talk. I think you give the point specific. Thank you very much. And I would like to introduce Georgia Sarkela Brugada, who is a really a friend of mine. And I will just make a brief summary because his curriculum vitae is very large, but he had a Bachelor of Medicine in Bell Beach, and then a specialization in pediatrics in the Mutua de Terraza University Hospital, then a diploma for advanced studies in child pathophysiology, a master's degree in pediatric cardiology, and a doctorate in child pathophysiology. If that is not enough, she has international experience in catheterizations in congenital heart disease in Montreal, Canada, and after that, she worked at the Necker Hospital in Paris. Georgia, welcome as a ISHNE young member, and welcome to this webinar.
Thank you so much. Thank you, Manlio, and thank you for calling me young. Actually, I have to say that I was named senior, so I was very upset. So that's why probably Manlio decided to say that I'm the young invited. Thank you, Konstantinos. That it's been a great pleasure hearing your talk, and there is so much we need to learn. I think what we are more or less good at reading ECGs. We are more or less good at reading what those wearables give us, but we are absolute ignorant on what we have behind that. And really, from the perspective of as doctors, I think we should be humble enough to say we are. This is over our limits. We need to walk next to engineers, people who's absolutely masters the AI and data and data collection. That's absolutely important. And of course, to try to get the most of it. There was a very important point on who's the owner of those data. This is something that I have discussions here in the hospital. We have an amazing platform, what we call Clinical Command Center. It's an amazing platform on all type of wearables to follow up children. I work in a pediatric hospital, and we have critically ill patients that are at home. We have patients with diabetes. We have patients that are monitored for many things, and of course those data belongs to the patient. And of course, it's the system who pays for it. And of course, this helps us mainly in the pediatric world of rare diseases. This belongs to the the system itself to improve the quality of diagnostic and how we are going to treat our patients, and if this can help on the follow-up of our patients. And this is so important, especially in rare diseases, especially in cardiac rare diseases, but with all rare diseases that we have little information. All those things that will help us improve the knowledge will, of course, help others to have an earlier diagnosis, to have an appropriate treatment and appropriate follow-up. We are talking about chronic diseases most of the time, and using those wearables will make the life of those kids, in my case, no, but of those patients, more feasible, less feeling like I'm a patient and I'm a sick person, and more as a normal person. And I think that's the very good point of it. Which are the gaps? And that's important. Which are the gaps? Mainly pediatrics. There is very few devices that have been approved for children, but of course, just as an example, to use the Alive Core, Cardia Alive Core, we need to just lie to the system and say that the date of birth it's at least 18 to make sure that we can use. Otherwise, we cannot use it, and the system blocks. So you have to just lie, say a little white lie, to just make it work. So of course, I understand, and we as pediatricians, we understand that those devices, in order to have the pediatric use approval, it's an extra cost of money for the companies, but this is an obligation. And I think from the strength of the scientific societies should be on make those more vulnerable and less common patients to be able to reach that equity in reaching those devices. And I would like you to just, if you know much better than me on those topics, but if you could give your opinion about that as well.
So I totally agree. I totally agree with you, and thank you very much for very, very important comments. The important thing is that we should also, regarding the data ownership, it is very important what you already said. I think that it plays a big role, the perspective. For example, there are a lot of patients that they say that I don't want to share my data, I don't want to be part of studies or part of AI algorithms. But when you speak with people with rare diseases or children with rare diseases, or where their parents, they say that, of course, we want to share our data because it will lead to a new therapeutic approach for our child, for example. So it's very important. Regarding the second comment, I should agree with you, and I think that the companies should invest more on addressing and developing tools for the child population. But on the other hand, I think that as a scientific community, but also as a regulatory structure, we should work in order to have a common, or let's say more or less a common pathway on how to validate and how to really assess the safety, the accuracy of such devices, and how this would be safely implemented in the daily life and in the clinical workflow.
Yeah, thank you. And how do you think that we could just make sure that we have all the raw data available for that? Because in fact, this is something which I usually ask the companies. I say, of course, and I need the raw data. And it's kind of, oh, well, we need to just move forward to, the upper level of the company to have that. And it's like, well, shouldn't this be the normal? I mean, why? Of course, that data, it's making their algorithms to be better, but of course, I want their algorithms to be the best of the world, but for the improvement of my kids or my patients. So how can we deal with that? How should we focus?
Okay. So that's also an interesting question, but I think it's a time, it will need some time to mature. I think if we see how clinical studies were done 30 years before, for drugs or for other devices. It changed a lot during the time. So I think that the same will be, but in a more fast-paced way, also for the digital tools and for the companies. But this is where, as I told before, we as scientists, as doctors, we should push more through publications, through public advocacy, and we should also work together with the health ministry and also the companies but also the patient association, that we all understand that we are on the same boat, that we have the same direction. We as doctors, we don't want to interfere with the industry and what they have as a goal, but we all should work for the general public wellness and well-being.
Thank you. I think that Adrian, please, if he can be in. Thank you. Oh, we don't hear you. You are muted, Adrian.
Thank you very much. And if we can have also Dr. Vasilikos in, that would be great. So thank you so much, Dr. Bakogiannis. It was an excellent presentation. Georgia, the exchange, the questions were fantastic. So thank you so much. It's a real pleasure to have you here. But if we can have Dr. Vasilikos, he had a specific question that he would like to share with both of you. Let's see if we can have him. Here he's coming. Go ahead, Vasilios.
Hi, congratulations to all. Excellent presentations. Actually, it's just to make things a little bit easier for everybody. My understanding is that we have the revolution of technology, and we're not ready, or some countries are more ready to accept this compared to other countries. And also there are lots of social differences and politics, if you want, in the different countries. But I see that a common thing. Everybody wants to know what's going on, and when they have this information, they want to have it quickly, and the diagnosis should be very easy to get from the doctor or the institution back to the patient. So I would just keep in mind that AI is going to give this it's going to be a big advantage on how to manage all this data and make the diagnosis and the approach to the patients more democratic, if I may so. And the other thing that we learned, Kostas Bakogiannis mentioned that, is that we had lots of problems. We thought that we could communicate very well with our patients, but during the last 3 years, we understood that we didn't do. So we started building up a new relationship, and I think part of the problem is to know what the patients want and don't make them feel worse. Thank you very much.
Thank you, Vasilios. Konstantinos, would you like to make a comment on what Vasilios just said?
Yeah, I think that and that's why I found the paper of Dr. Rosman very interesting, because we see that we are different. So most of us have different behavioral concept, personality types. So, and I think part of the personalized medicine that we have a lot of discussion is also to recognize the personal identity, the wants and the needs of each of us, and try to find the best or the optimal tool. And that is part of our role as healthcare professional, to find the best tool for our patient and maybe for also individuals that might be healthy and want to prevent. So I think addressing the individuality, but also be aware as healthcare professional, be educated regarding the tools, knowing the limitation, knowing the potentials. It's, I think, the way to go.
Thank you very much. Well, Vasilios, if you're okay, with no further ado, I will introduce our last speaker.
Sure.
I could spend hours telling about his CV. However, what I would like to highlight about Professor Neeraj Verma is that he is the mind behind the development of the wearables and the understanding on how to get the best possible benefit for patient care on detecting arrhythmias using wearables. So he has led the international consensus. His paper in 2017 has above 250 citations. He has impacted the world with his understanding about wearables. And as a past president of ISHNE, it's a tremendous privilege for all of us to have Neeraj giving us the last lecture on this topic. Neeraj, the floor is yours. Thank you so much for being with us today.
Thank you very much for that glowing and unnecessary introduction, Adrian. Thank you. Thank you to the chairs, Professors Baranchuk, Vasilikos, Marquez for inviting me, to EHRA and ISHNE for hosting this, and to the faculty for their terrific presentations. So I'll begin with my exposure to remote monitoring. It really began with implantable devices 20 years ago. And what I'm hearing just now is that the challenges that the community encountered 20 years ago are identical and perhaps amplified to the ones that are being encountered now. But there is a difference in culture, because 20 years ago when remote monitoring came along, I think most in the EP community were resistant. It was quite a paradigm shift. It was a cultural shock. But the change now is that the young community regards this as the norm. Internet-based care used to be a shock 20 years ago, but now it's the norm. So that is a huge transition. But many of the challenges that were encountered with implantable device remote monitoring are similar to the ones with wearables. And in those 20 years, there has been progress, but not resolution of those challenges for implantable devices. The last guideline for implantable devices a year and a half ago really focused not on applications, but on managing the data and maintaining connectivity. And you've heard from the discussions earlier that this is the challenge just now for wearables, but scaled up compared to implantable monitoring. There are also practice differences, significant ones. For implantable device remote monitoring, there's a well-defined workflow, which really follows traditional appointment-based care. It's controlled, it's prescriptive. This is very different to wearables, which is patient-driven, real-time information, and a demand for real-time response, which really does challenge clinicians and hospitals in terms of managing those responses and expectations and managing the data. So we shift from the physician controlling the data ingestion into the clinic to the patient-driven workflow. So this is a significant challenge, as you've heard earlier. The other thing that we discovered with implantable devices when we had the ability for continuous monitoring was that the value of those data were questionable, such that almost 90% of the input data were non-actionable, clinically non-actionable. So what do they mean? That means our services were overloaded, still are overloaded with non-actionable information. I think one of the largest applications of AI would be to filter the actionable information, so reduce workflow, but enrich the information that is coming from wearable devices. We also have to assess false positives. AI has an important role there. But I would also bring to your attention that not all wearables are created equal. There's a lack of validation. And even when they're validated, what is the value of a true positive event, for instance, atrial fibrillation? A lot of the literature, the majority of the literature in the EP community at least, has addressed atrial fibrillation. So that's a good example. Now that we have high granularity of atrial fibrillation events, how much matters? Is it 10 seconds? Is it 6 minutes? Is it 24 hours? These are questions which are slowly getting resolved, but this becomes very important in terms of directing therapies and improving patient outcomes. But that is if we have consistent monitoring. And the behavioral aspect of wearable remote monitoring is very important, as highlighted by our last speaker. Implantable device monitoring is prescriptive, so we can control the data. But patient-driven wearable monitoring really depends on the patient. And there may be psychological issues. From a clinician's point of view, the consistency of the transmissions is very important. So adherence has been a huge problem in wearables. There's a steep drop-off in adherence in most wearable remote monitoring. So can we rely on this information? Connectivity, again, a shared challenge between implantable device monitoring and wearable device monitoring. So we have a true positive event, and we may not know what to do with it. So a patient is labeled as having atrial fibrillation. And this extends on the points made earlier on privacy and data management. Technically, a patient may have a diagnosis of atrial fibrillation, and this may affect applications for life insurance, for mortgages, etc. So these are serious social implications which really haven't been addressed. But there are many, many advantages of wearable remote monitoring that we can envision for the future. We can include the patient in their care pathway, individualize to their condition, follow the dynamic nature of disease and also risks associated with therapy, follow these real time, and integrate management of not only just a single disease, but of multiple comorbidities, for instance, which cardiovascular patients are vulnerable to. AI may have a huge application here. Already, at least in the world of implantable devices, again, as an example, as an analogy, there are heart failure algorithms built on AI processes which may predict impending heart failure, permit earlier intervention, and therefore prevent hospitalizations and improve patient outcomes. So that's a huge promise that we may be able to achieve with wearable remote monitoring. And as we look to the future, there are many other biosignals that we can follow. Most of the data, as I said, has been for atrial fibrillation, but there are many other diseases that we could follow. There are new applications, for instance, unwitnessed sudden cardiac death. We've really made no dent in that very risky condition because 95% of cases lead to death. But unwitnessed cardiac death using wearables, integrating ECGs or PPG heart rates and accelerometers to assess falls, breathing parameters. These can be integrated and perhaps signal to a dispatch center early intervention, and we could improve on sudden cardiac deaths of ventricular fibrillation. So many applications within arrhythmias and associated cardiovascular diseases. So I think the future is very exciting for wearable remote monitoring. Thank you.
Thank you very much, Dr. Barma. It was a pleasure to hear you. I have just one question to start this time for discussion that we have. You mentioned that it is a change of paradigm because we are changing from physician-controlled diagnosis to a patient-driven diagnosis. So my question is, are we ready for that as physicians? What do you think about that?
Yeah, so when implantable device remote monitoring was launched 25 years ago, physicians were shocked. But now it's the norm. But it took 10 to 15 years for this to become standard of care. And even after the first guidelines giving this a class 1A recommendation were published for implantable monitoring, the adoption was very slow, very slow. So my answer to your question is that physicians are never ready, because as a group we are conservative and we don't like changes in practice. But I think we have to be more agile now with wearable remote monitoring. This is here to stay. It is embraced by the young community. This is standards for them, so we have to adopt accordingly. But we have to avoid unnecessary communications, perhaps use mechanisms to simply be alerted, so alert-based care, alerted to the actionable information, which may only represent 1 to 5% of the traffic, of the internet traffic. And then when we have mechanisms to react appropriately, then we will improve patient outcomes. So I think these are the two holy grails of remote monitoring: improve patient outcomes and improve hospital workflow.
Thank you very much. I will like to ask Dr. Bakoyanis about digital health literacy. What barriers do we have at this moment to increase this digital health literacy? What do you think about that?
Well, that's a very, very, very nice question. Thank you. I should say that for us, for example, working on this project, the cardio school, one of the challenging topics is actually to learn to speak the same language with the patient, to speak in a way that we can communicate not only with the patient actually, but also with the industry and the other stakeholders of the ecosystem, of the digital ecosystem. On the other hand, that what we have already discussed with Professor Varma in the past, we have successful stories. For example, the patient with diabetes, that they are currently using successfully their apps, and they can regulate in a very controlled way their blood sugar. So I think that we should, let's say, work more constructively, more creatively, and I think that the barriers are manageable.
Okay, thank you. Thank you very much, Konstantinos. And for Dr. Thomas, what about using multiple wearables? I have just seen a patient with one smart watch in a wrist and another device, I don't know the name now, in the other wrist. So what do you think about using multiple wearables?
Yeah, that's a very good question. And I think it's a kind of a little trend, towards multimodal data acquisition, as Professor Varma mentioned, that we're gonna collect data from different devices. So one thing is what you have on the wrist. The other thing is what you have in your ear, or even how you speak. So voice technology and voice biomarkers are growing. So I think yes, as I show you one slide with almost 20 possible wearables you can have on you, is that really, I think that smart clothes and voice technology will be like integrated into one.
Thank you very much. I will let Vasilios to continue.
Yeah, thank you. Thank you, everybody, for this very vivid meeting. It's clear to me that we are, let's say, the older generation, but we think like a young generation, right, Georgia? And we feel that we're still young and everybody laughs at us. But anyway, I think life goes on. Technology is here, and what everybody said and Professor Varma said is that we cannot, we have to be in the boat, we have to be in this train. So we have to retrain ourselves, the way of thinking, and I'm sure that medicine that the next generation are going to practice is completely different than the clinical medicine we used to practice. But that's not a bad thing. One of the important issues is that this kind of discrimination, let's say we live in the perfect world, we overcome the problems of lots of data, how we're going to use them, false positive, false negative, etc. So we have a very good way of filtering. So all the details we're getting, the information is correct. What do you think about creating different subgroups of people or potential patients that they're going to be treated differently? We had this chat with Professor Varma some time ago. If you remember, Neeraj, we both tried to lose weight because the insurance companies increased our premium. But anyway, that's true. That's true. So I don't want I just want to make a note that technology is there, medicine is there, education is there, but the government and the legal part should be there. I know that in Europe we are more, we are late on this. In the States, you are not as slow as we are, but this is a problem. What do you think?
No, it's a very interesting comment. I think that's a wonderful analogy. I'd forgotten that, but it is very important. So doctors can say lose weight to their patients. Doctors can say it to each other, but nothing happens. But the moment there is an incentive, such as an increased premium or a reduced salary, then people will abide by it. So this, I think, illustrates that behavioral modification or behavioral management is a critical part of this. So we don't really, as physicians, I believe, at least not in my training, we've not really paid attention to behavioral therapies. But that, as Dr. Bakianis showed, there are interesting data from behavioral scientists that recognize these challenges, and they have ways of intervening to change behavioral, to execute behavioral modification, basically. So people will align with medical therapies, will align with monitoring, and become more health conscious. And I think this is something that can be empowered by wearable monitoring, not by implantable device monitoring, because that's only one-way traffic. So I think there is a huge opportunity here for patients to take part in their own care, and also for us to bring in a different mechanism for compliance.
Yeah, that's great. Georgia, what do you feel about, how the kids are responding to this? Do they like,
Well, it's so easy. Kids were born with a phone under their arm, so it's so easy for them. It's so integrated. Sometimes with those devices that are connected to the mobile phone, we have the problem that they cannot be punished without phone because they need the phone to connect with whatever we want to check. So it's a way that parents lose one opportunity for punishment. It's like they cannot just get phone down and they say, oh no, it's the doctor who said I need to take the phone. But incredibly, they are the ones that they download the app and they, it's part of they feel so well. And actually, most of the time we have false alarms because all the algorithms are made for adults. And of course, having a child at 110, the alarm will just beep. But they already know how to change the alarm settings and everything. So they are the ones doing that for their parents. So I think this is not the problem at all. And I think, believe it or not, they are going to be the ones teaching us how to do it. And welcome. I mean, more than welcome for that.
Yeah, great. Thank you very much. Adrian, do you want to add something?
Very quickly, to invite all the audience to the next ISHNE meeting to be done in Thessaloniki, in Greece. You can see it in the screen, starting on May 30th to June the 1st. Dr. Vasilios has done a program that is absolutely amazing, and it will be a pleasure to see all the speakers today, but also all the people in the audience. Vasilios?
Yeah, thank you, Adrian. So I would like once again to congratulate everybody. I'm very happy. I know that the timing is not the perfect for some of you, but again, thank you very much. Thank you, Consultor, who made this webinar possible. And also, I would like to thank the audience for their patience. And also, I would like to invite you again, as Professor Baranchuk and Professor Marquez said, to Thessaloniki in our meeting. We hope, except the scientific part, we think that it's a very nice scientific. We have a very nice scientific program. We have webinars. So we have workshops on ECG, on pacing, and also we have sessions for the young fellows who are going to have direct mentoring from the pioneers. And we try to make it a little bit more different. I hope that you will be able to join the meeting. And I have to remind you that time in Greece, it's the best time to visit Greece and the antiquities and the history. Thank you very much, everybody, and see you soon. Bye.
Thank you very much.
Thank you.